In this lesson, we're going to talk about how some of the instruments might fail while you're trying to use them for your instrument flying. There are three fundamental skills of instrument flying: instrument cross-check, instrument interpretation, and aircraft control. All three are important, especially if things start to go wrong. Instrument cross-check is checking for errors and reading each instrument in the context of the other instruments to make a clear picture of your situation. Instrument interpretation is understanding the information that your instruments are trying to give you within the context of aircraft performance and systems conditions. Aircraft control is inputting the correct measured controls to make the aircraft do what you want to do. When we're interpreting our instruments, there are a couple of approaches that people take. Both are important. They are primary supporting and control performance. We'll start with primary and supporting. Looking at things this way, the pilot controls the aircraft by dividing the instruments into the primary means of information and the supporting means of information, depending on which task is being done. The primary instrument is always going to represent the goal of the maneuver, while the supporting instruments are those that give similar information with regards to the aircraft's pitch, bank, or power that you can use to check the accuracy of your primary instrument. In this technique, the attitude indicator is only ever primary during transitions from one maneuver to another, when your goal is to change the aircraft attitude. This technique forces the pilot to control the aircraft using other instruments during most activities, preventing fixation, improving scanning technique, and giving you the skills needed to maintain control in case of a vacuum failure. There are a lot of FAA test questions on this way of looking at things. These instruments can all reflect the aircraft's pitch attitude. If we are trying to hold a constant airspeed, such as in a constant airspeed climb, the airspeed indicator is the primary pitch instrument. It tells us whether our pitch attitude is correct for holding the airspeed we want. If we are trying to hold a constant rate of climb, then the VSI is primary for pitch. If we're trying to hold altitude, whether in a turn or straight and level, the altimeter is primary for pitch. We only use the attitude indicator as primary pitch instrument if we're changing our pitch attitude, such as transitioning from straight and level to climb. In each case, the other instruments are supporting. It's worth noting that primary does not mean you should look at that instrument as you make your elevator inputs. Primary is where you look to see whether a change is needed. If you are partial panel and using the magnetic compass to hold the heading, then the compass is primary for bank. If your gyros are working and you're trying to hold the heading, then the heading indicator is primary for bank. If you're trying to maintain a standard rate turn, then the turn coordinator is primary for bank. Once again, the attitude indicator is only primary as you transition to or from a turn. Both airspeed and the tachometer, or manifold pressure and tach in a constant speed equipped aircraft, are your power instruments. If you're trying to maintain a specific airspeed, your airspeed indicator is primary for power. If you're trying to set a new power, then your engine instruments, either the tachometer or the manifold pressure and tachometer, are your primary instruments. We can create a chart here that helps you see the primary and supporting instruments for each flight regime. During straight and level flight, your goal is to maintain a constant heading, straight, and constant altitude, level. Your primary instruments will be the ones that you're trying to hold still. For straight and level flight, your primary pitch is your altimeter, since you're trying to hold it still, and it tells you whether you need a change in pitch. And your heading indicator, abbreviated here as DG for directional gyro, is primary for bank since it's the one that you're trying to hold still, and it tells you whether or not you need to change your bank. The other pitch and bank instruments take a supporting role and aid in checking the accuracy and possible instrument systems failures. Supporting does not mean they're unimportant. In fact, it's very important to cross-check your primary and supporting instruments. Primary only means that the altimeter and heading indicators are the ones that you're trying to hold at a certain value. During a constant airspeed climb, your goal is to maintain a constant speed and a constant heading while you climb. When taking the FAA written test, be sure to pay close attention to which thing you're trying to hold constant, as this will tell you what your primary instrument is. For this reason, during a constant airspeed climb, your primary pitch will be the airspeed indicator and your primary bank will be your heading indicator. Again, the answer to the question is almost given to you in the question. In this case, if you're asked for primary pitch instrument in a constant airspeed climb, constant airspeed is the key words to help you figure out which instrument is primary for pitch. We're trying to hold the airspeed indicator at a certain value, so it is primary for pitch. During a constant rate climb, your goal is to maintain a constant rate of climb and a constant heading. For this reason, your primary pitch will be VSI, and your primary bank will again be the heading indicator. When performing a standard rate level turn, you're attempting to maintain your altitude while turning your aircraft at a standard rate. Your primary instrument for pitch will be your altimeter, while your primary bank instrument will be your turn coordinator, since it gives you rate of turn information and it is the instrument for which you're trying to hold constant for bank. Note again that the attitude indicator is not listed as primary for any of these, but it is primary if you're transitioning from one regime to another. So keep your eyes open for the word transitioning or establishing for times when the attitude indicator might be primary. Next, we'll talk about the control performance model. Power plus attitude equals performance. That formula guarantees you that if you select an appropriate power setting and place the airplane in a constant attitude, the airplane will give predictable future performance. Your capability to predict, anticipate, and correct for the airplane's future performance is key to operating high-performance aircraft smoothly in IMC. To enforce that rule, you must be able to hold the plane in a constant attitude. To maintain a constant attitude or to change your aircraft's attitude, you need to focus a little more on the attitude indicator. The attitude indicator is the only instrument on the panel that gives you instantaneous and direct information about the airplane's pitch and bank attitudes. You can and should create a table of aircraft configurations that result in the desired performance for a variety of common IFR tasks, such as this one for a Cessna 182. Your table may look different if you have a fixed pitch prop or retractable gear, but the concept is the same. In this discussion, the term power is used in place of the more technically correct term thrust-drag relationship. It is implied that you have to take into consideration the flap and the gear positions as well as the power setting when setting the power to achieve the performance that you want. The control instruments display immediate attitude and power indications and are calibrated to permit those respective adjustments in precise increments. Control is determined by reference to the attitude and power indicators. Power indicators vary with aircraft and may include manifold pressures, tachometers, fuel flow, torque gauges, etc. The performance instruments indicate the aircraft's actual performance. Performance is determined by reference to the altimeter, airspeed, or vertical speed indicator. The navigation instruments indicate the position of the aircraft in relation to selected navigation facility or fix. This group of instruments includes various types of course indicators, range indicators, glide slope indicators, and bearing pointers. Newer aircraft with more technologically advanced instrumentation provide blended information, giving the pilot more accurate positional information. Let's talk about instrument cross-check. A novice student might cross-check rapidly, looking at the instruments without knowing exactly what to look for. But as you gain experience, you learn to be methodical, deliberate, and efficient at your cross-checking. We always say that a pilot should trust their instruments while flying IMC, but trust has to be earned. Referencing instruments that give similar information but run off different systems is a good approach. For example, we tend to glance at both the heading indicator and the turn coordinator for bank, which allows us to see quickly if they start to diverge. There are a variety of scanning patterns that work in different situations. Here the rectangular scan is shown. If followed in this order, starting with the VSI, it presents altitude trend, current altitude, aircraft attitude, and airspeed, the heading trend, and then the heading. It works well as a way of monitoring routine progress. The inverted V works well if you're just trying to hold things constant while performing other tasks, such as communicating with ATC. During these times, taking in a bunch of numbers off the other instruments might be distracting. The radial scan, also known as the hub and spoke, is a great all-around pattern that is especially useful when transitioning from one flight regime to another. You should be familiar with some of the common scanning errors so that you can recognize them when they happen. Emphasis sounds like a positive attribute, but it can be harmful to your situational awareness if taken too far. This is most commonly happens when you're overloaded, when your natural tendency is to start leaning on the instrument that is most easily understood. There's a very real danger that you won't recognize when it is either not good information or is leaving out part of the picture that is important. Similarly, fixation is staring at a single instrument, which usually occurs for a reason but has poor results. Maybe you shot through your altitude and now you're staring at your altimeter wondering how on earth it got there. While you're staring at the altimeter, you fail to notice that you've started to turn off course. Omission is another serious error. This is when you just plain skip over one of the instruments. Which one is missing here? It's the VSI. Without that information, you might see that you're slightly below your assigned altitude of 1,000 feet, but miss the fact that you're already in a slight climb because you didn't look at the VSI before correcting. This results in an overcorrection. Instruments can also fail. We've talked a little bit about this before, but it's important, so let's review. You should continually monitor all instruments to ensure indications correspond to other instruments so you know when something is going wrong. Understand which instruments run on independent systems, vacuum versus electric, for instance. If an instrument has failed, cover it up immediately with a sticky note or other item if you can. It may be difficult to ignore its false indications otherwise. The most common partial panel situation in the small aircraft we fly is the loss of the vacuum-powered instruments, which are the attitude and heading indicators. You should immediately inform ATC if this happens, even if the aircraft is under control and you feel comfortable handling the situation. Apply gentle, precise control inputs to compensate for the lag in the instruments. Be patient. If you're straight and level, altimeter is primary for pitch, the compass for heading. In turns, the turn coordinator is primary for bank, with the compass being primary for the heading, and you can use the altimeter, VSI, and airspeed for pitch. Make sure you keep the airplane in trim to make your job a lot easier. Usually we train for this by covering up your instruments right away and having you fly without them. However, in real life, your vacuum instruments will fail slowly as suction is lost and they spin down. This can be especially difficult to detect, so again, cross-check your instruments continuously to catch if something is amiss. If one vacuum gyro has failed, they are likely both inaccurate. You should take a glance at your suction gauge, which may verify the failure. You should cover up failed instruments if you can reasonably do so, as it's going to be hard not to include them in your scan. In most small airplanes, the magnetic compass is the only direction indicating instrument independent of all other airplane instruments and power sources. If we lose our vacuum system, we must use it for the heading information, but care must be taken on relying it due to the compass errors discussed in the previous lesson. Remember UNOS, undershoot turns to the north and overshoot turns to the south to compensate for the lead lag errors. The amount you need to overshoot or undershoot a turn depends on the direction you're turning as well as your latitude. A good rule of thumb for calculating this is to roll out 15 degrees plus half of the latitude before or after depending on the direction. You can adjust this number for intermediate directions if you're not turning to exactly north or south using the formulas in this slide. Obviously, you're not going to be in position to do these calculations while you fly, so it's good to think this through ahead of time. For our areas, these should work out for you. You can always use these and make small adjustments after you roll out. Given how far outside your scan the magnetic compass is, a timed turn is probably the best way of turning to a specific heading after a vacuum failure. A standard turn is 3 degrees per second, so 360 degrees in 2 minutes. As you know, you're making your turn standard when the turn coordinator shows the wings on the white tick marks. Establish a standard rate for 30 seconds and you should turn 90 degrees. In addition to memorizing these times for heading changes in this picture, it helps to remember that each big number on the standard instrument is 30 degrees, which is a 10-second turn. Consider making half standard rate turns for small heading changes, which is 1.5 degrees per second. You can see the previous lesson for a detailed discussion on how these instruments fail and why. A total blockage of the entire pitot-static system is rare, but hard to diagnose. Double-check your aircraft's orientation with regard to your other instruments. Listen to the wind and the engine. Does your aircraft seem to be going fast or slow? Is the stall warning sounding? If you suspect a pitot-static problem, it helps to know a power setting and a pitch attitude that will result in a predictable, stable climb, and go to that if you're confused. Once you're stable, you can figure things out. In other words, fly the airplane first, always. Knowing how to recover from unusual attitudes is really important, since the flight instrument failure or temporary loss of situational awareness can mislead you into one of these attitudes. In this picture, we see that we are gaining altitude on the VSI and altimeter, and this is verified by decreasing airspeed and the attitude indicator. So we're in a nose-high attitude. The first step in an unusual attitude recovery is always the power. If we're nose-high, we add full power as our first step. Second, we use forward elevator to lower the nose in order to avoid a stall. And then finally, we make a smooth, coordinated rudder aileron input to correct the bank. In this case, the VSI and altimeter say we are descending, and it's verified by the attitude indicator and increasing airspeed. The turn coordinator and heading indicator agree that we're turning hard to the left, so we are in a nose low attitude. Once again, power is first. We reduce the power in order to keep from overspeeding. Next, we have to correct the bank so that we don't pull too many G's during the next step. Finally, we apply back pressure to pull the nose back up, being careful not to overshoot or do it too quickly. All of these things can be practiced either on your own or with a partner in the sim room so that you can avoid spending a lot of aircraft time on it. Make sure to put in some time on all three of these things. Attitude instrument flying with increased levels of turbulence using all of the scans and techniques that we've described here. Attitude flying with various instruments failed, and then recovery from unusual attitudes. Also, make it a point to know the pitch power combinations for your aircraft to make it do what you need to do.